Okay, so I have a topic for you today. It's called setting up data-driven tests with Java tools. So I know that some of you, if not most of you, are working with Java, and you write applications for a living with different architectures, whether that's microservices or monoliths or something in between. But no matter what kind of architecture you are working with, it's very likely that you eventually have to talk to a database. And when that happens, and if we know that we follow the best practices or the good practices for developing software, we have to test. But testing with real databases is a bit of a pain, right? It's a bit of a problem. But what if that wasn't the case? That is the whole point of this session. So if you have had trouble in the past building test cases that have to talk to a database, or if you are about to, then you are the right place. So my name is Almiray. I'm currently working at Oracle. My official title is Senior Principal Product Manager. But because I love source code so much and I work with open source, I would like to call myself a seasoned sorcerer. So if you happen to use open source, and if you want to know more about open source, I'll be very, very happy to talk to you about these things. Anyway, so here's the agenda for today. We have about a little bit more than, at most, 50 minutes. So we'll be seeing what is the current state, where we are in the audience, what kind of tools that we use, and for developing applications and frameworks and whatnot, and what is the current state when we're dealing with testing with databases and data-driven test cases. Then I'm going to showcase a handful of testing tools that you can use, and also going to showcase a specific database. You'll see why I would like to showcase this particular one, and then we'll go to some demos and finally some resources. Okay. So what is the current state? Well, that's a little bit white. So as I suspect most of you use Java, right? So let's see some hands. Who started using Java 2 years ago? Who's new to Java? Just a handful. So 5 years, 10 years, 20 years. OK, so here is the real test. Who's been using Java since 1995? Wow, just 2 hands. OK, but most of you are using Java for quite some time, so that's pretty good news. I'm not going to ask which versions of Java. Developing applications, you can do it in many, many different ways. There are some frameworks that have been coming up to the surface as the most popular ones, so these are the ones. Definitely the Java ecosystem, for those that are quite new to the ecosystem, it doesn't lack option. Some people believe that Java has too many options. There are too many frameworks, too many libraries to provide the same behavior. Well, it's a nice problem to have because then you can pick and choose. So in the case of developing applications for whether it's microservices or web apps or command lines or what have you, so these are the most popular ones. So let's see some hands. Who uses Spring technologies or Spring Boot technologies? So it's close to 80% of the audience, which is kind of what I see in the service. Most people use Spring one way or another, whether it's a Spring Framework, Spring MVC, Spring Boot, or some other thing that is based upon Spring. So who is using Quarkus nowadays? So a few hands is almost 5%. If you believe the service, Quarkus is about 15% now of the market share. Now, who is using Macronaut? Just a handful of hands also. Macronaut has about 5% of the market. Anyone using Helidon? Helidon is based on MacroProfile. Anyone uses MacroProfile or Jakarta EE? A few hands? Yeah. So in the past, it used to be very popular. But nowadays, as you have seen, Spring Boot is pretty much the king of the hill. It's the one that has dominated the market. So the good thing about these frameworks, regardless of which one you have chosen or which one you have to use in your daily work, they have good integrations with the tools that we're going to see today. So you don't have to start from scratch. You don't have to switch from your popular framework or your framework of choice. to another one in order to use the tools that I'm going to showcase today. All right? So you may have some questions when it comes to testing databases. So in the past, and I had to go through this when I was in my times when I was a consultant, when we needed to write test cases that had to talk to the database, we would just call someone in the IT department and said, hey, how's it going? Hey, can you please provide me a particular instance of this database software with this version and these characteristics so that I can test? And he will reply, yeah, sure, why not? And 3 months later, I will get a different version. And will not get admin rights in order to do the setup. So imagine that after all that time, I was able to finally get some sort of an instance that I could use. And now that instance is only for my personal use when I was testing. Because if I were to share this with another teammate, how am I going to assert that if I'm running a test case, he is not running a test case at the same time, and we are stepping on each other's toes, so the database state is different, and my test cases will fail because he added more data into the database and vice versa, right? And then a few years later, we found a way to figure this out. Yeah, everybody got their instance, so we had to pay more licenses, or even worse, instead of using the actual software, whether it's Oracle, Postgres, MySQL, we will run an in-memory database like H2 or SQL DB, which at first it sounds like a good thing and a good idea. Hey, it's in memory, it starts very, very fast. What if you need to test a very specific feature that only that database vendor gives you? What if you need to test stored procedures, PL SQL, something else, some data type that the in-memory database does not support? Yeah, that will be a problem, right? We cannot simply say to our manager, I was not able to achieve 100% of coverage or whatever number of coverage because our testing tools are not adequate. That is not a right answer. We had to find answers, right? That's what we're being paid for. So that wasn't working correctly. And years later, we got finally CI servers. We can now build on remote servers. And years later, we got the cloud. So pretty much the same thing. You don't have to manage the servers, but we're back to the same problem. If someone is managing an instance outside of your testing environment, how can you be sure first that the instance is up, is the right version, has the right state, has the right conditions? No one else is touching that database and that state so that you can do your test properly and get the right results. See? So how can we solve these problems? Well, we just have to select the right tools. There are a handful of tools out there. Some of them harken from many, many years ago, and some others are more recent. So first, I'm going to talk about, it's 4-ish tools, because I will expect that most of you, if not all of you, know this one, JUnit. JUnit 5 is the latest edition. He's been running for, I think it's about close to 10 years now. Anyone here uses or used to use JUnit 3? I'm not even asking 4. 3, yeah, it's that old. Exactly. So there are other testing tools that you can use in the Java ecosystem. So there's TestNG, there's Spark, but JUnit, and pretty much JUnit 5, is the de facto standard. It provides nice features, such as you can use Lambda expressions to have lazily evaluated blocks. It has other modern features, well, annotations, obviously, that JUnit 4 and JUnit 3 did not offer back at the time. So, long story short, if you have not dealt with JUnit 4 or JUnit 3, you're good. Don't delve into the past. Don't go there. Stay with JUnit 5. So the other tool that I want to talk about is DbUnit. This is an extension to the original JUnit test framework. I think that this came out around JUnit 3, so this is almost 20 years old. And the basic idea behind DbUnit, this is one of the things that I like back in the day. Again, I used to do a lot of database testing. What this tool allows you to do is set up a database state. Someone has already been running a database instance. You had to figure that out. We'll see that in a moment. But given that you already have a database instance running somewhere, then you connect to that database and see a particular state that is, the schema has already been created. So the only thing that you need to do is add data to the tables and the sequences and all that. So you put that in the right state, execute all your test cases, and at the end of each test case, of all of them, it depends on what you need to do, you can assert and you can verify the database state. Now, I know that for those of you that say that you're using a Spring Boot, there are options for you to fill out the original state or the first state for the database, run your test cases, and then do assertions also using the Spring Boot libraries. Now, the thing is, or even your own application code based on Spring, the specific problem that happens here with this kind of verifications or assertions is that what if we made a mistake in our own assertion code? What if there is a hidden bug in the libraries or the dependencies that are coming from a Spring Boot? So we might be getting a red test or a green test when it should be the other way around. It would be better, perhaps, if we can go one level down instead of the application level, try to go as close to the database and do the assertions. Try to remove as many layers as possible to go to where the data is. And this is exactly what DbUnit does. It allows you to put the data in the database without relying on anything that has to do with Spring or Quarkus or any other framework. And once you're finished with the test cases, it also allows you to do comparisons, do a diff within the different data sets that you have in the database and data sets that you may have in external files that had to follow a particular format. So this is basically the idea behind DbUnit. There are other features that are built on top of that, but this is how I got started. And just on a personal note, this is one of my first open source projects. So I did not start this one, but I started collaborating to this open source project back in 2006, so it's almost 18 years ago. But as good as DbUnit is, it has not kept up with the times. It still uses JUnit 4 semantics. It doesn't use JUnit 5 features. Well, there is this project called DB Rider, or Database Rider, which started as a JUnit 5 set of extensions for DbUnit, and it added more and more and more. So you can think of Database Rider or DB Rider as the DbUnit for JUnit 5. So it is usable with Spring and the other frameworks that I mentioned. You can use annotations, and it provides additional formats for you to seed the data and do the verification. So it's quite good in this regard. You will notice that some of these pages have QR codes. Those where if you take a screenshot of that, then you can go directly to the URL of that particular project. Are we going? We're OK? So far, so good? So far, the only thing that I've said is once we have a database running somewhere, then you can do stuff with it. But the first problem is getting that database, because you definitely don't want to talk to the IT person that might give you the wrong version of the software, or you will have to be in charge of setting everything up every single time, right? We don't want to do that. We just want to provide a solution. We just want to code. We don't want to deal with provisioning environments, or do we? So the other thing that we can see today is test containers. So I'm going to ask another question. Who doesn't know what test container is? Who's new to test containers? All right, perfect. Just a handful of hands. This is what I wanted to see. Because for those of you that don't know test containers, if there's only one thing that you learn from this session is you should be using test containers after you finish this session. I'll show you why. So basically, test containers is a way for you to launch software within a container. It will be a Docker-compatible container. You can run it with Podman as well. You can, there are other options to run this thing. But the basic idea is that instead of grabbing an in-memory database for testing your Postgres or Oracle, MySQL, SQL Server, what have you, you use the real database. But in order to do this, you have to use the real software. How can you ensure that you can bootstrap a particular environment, pristine environment, every single time that you need it, at the moment that you need it, with the right data, with the right configuration, every single time, reliable, okay? That is what Testcontainers does. And it's not just for databases, it's for all kinds of software. So if you have to deal with Kafka, or RabbitMQ, Red Panda, anything else like that, any kind of server that can be run inside a container will happily run inside Testcontainers. Now, Testcontainers provides some sort of configuration for you to set up what are the basic settings or the basic properties for each one of the containers that you want to run. So you can tweak, you can set a specific ports, you can set it for random ports, depending on the software that you're running within the container. You can also, well, Testcontainers will take charge of the life cycle. So it not only will bootstrap a container with the right conditions that you have specified, but at the end of the test case, it will also ensure that no other container is left running. So you don't have any zombie containers, you are not leaking resources. And because doing these kind of things, that configuring a particular software that you want to run inside a container may take, I don't know how many different settings. Testcontainers, or at least the company behind it, used to be called Atomic Jar. Now they're part of Docker. What they allow you to do, they have a set of what they call test container modules, predefined configurations for popular software that you can run on containers. Again, what I mentioned before, RabbitMQ, Kafka, Postgres, Oracle, MySQL, all these things that you really want to use as real dependencies. So you can run Testcontainers. It's open source. You can use it as is with JUnit. There is more than one version of Testcontainers in the sense that you can run it for Java, because it's a Java conference, but they also support Python, JavaScript, Node, and I think they're working on .NET as well. So if you have other colleagues that happen to require these other languages or other ecosystems, Testcontainers excuse me, has a solution for them as well. In the case of Atomic Jar and Docker, they also offer commercial products called Testcontainer Desktop for free and Testcontainers Cloud. This is something that you have to pay, which gives you additional benefits. So I am not here to sell you the idea of using other commercial things. I'm just saying these are the different possibilities. Just go and look for yourselves and see if it makes sense for you. So with that regard, I used to give this session with another person. His name is Oleg Shalayev, the developer advocate for Testcontainers. And this will be the right time for him to say, I'm going to showcase Testcontainers. But because most of you know it, this will be quite fast. And if it goes down in flames, it's because, yeah, it's a live demo. So this is a very, very trivial class that says, I'm going to initialize a container with a Redis image. I chose that particular image, 6 Alpine. I'm using a generic container. This is something that will work for any kind of software that you want to containerize. And you only have to point it to a particular Docker image that should be available on Docker Hub. OK? Now, I am not running Docker Desktop on my computer. I'm running Docker Testcontainers Cloud, which is the other version that I have access to, because I happen to be one of the Testcontainers champions, which you can have access to if you want to. But you will see that eventually there will be a connection of this container into some sort of Docker daemon, and we'll download that Docker image. We'll create a container. We'll bootstrap it. When I say ready to start is when I actually tell Testcontainers, I know you have certain configuration. Now I want you to run the server. This will bootstrap the real container. Then what we're going to print out is if the container is running successfully, then this should print out what is the current IP and what is the current mapped port inside the container for the spotted port that I'm doing here. Okay? And then I'm just going to stop it. If this works correctly, we should see, let's see what happens here. We get a printout right there, localhost, and that's the number of my ports, 32776. If I run it again, it might be a completely random thing. And one of the things that you can do here with a container is that if I want to say something else, I just need to do code completion, and this will suggest me what other things I can do with this container. Again, works for any kind of software. But the moment that you want to do this for Postgres or Oracle or MySQL and say, I want to use this username and this password with these environment variables and these ports and this and this and this and these other kind of settings, well, these things start to grow. You could put all these things in besides your own base class, your own base configuration, or you can use the Testcontainers modules, which already provide most of the basic configuration for explicit software. So I'm glad that this thing didn't blow up, so we can go back to the slides. And now I want to talk about database software. So I know we have many choices out there for running databases. I already said a few times, Postgres, MySQL, Oracle, and there is SQL Server, and so many others. All of this, you can run it outside of a container. Most of them can be run inside containers. And because I happen to be an Oracle employee, of course, I'm going to talk a little bit about the Oracle database, but not just because of that. It's also because it's very likely that either you have to deal with the Oracle database today, or you will eventually have to. Why? Because it's one of the most popular and used database software. It doesn't have to be open source, but there are options for you to use it for free. And I'm not saying this will be a watered-down version of the database that does a few things. No. This is the real database software that you can run on development, on testing, and on production, if you want to, for free. Yes, you heard that right. So one of the things that I like about the Oracle database is, and it's not the only one, other database vendors do this as well, is that if you're building an application, it's likely that you're going to start with relational data, right? But we have other choices. We had the NoSQL revolution that started like 16 years ago. We have document databases based on JSON documents, and we have column-based, and we have, what else we have? We have graph, and we have spatial. Now, all the rage is vector APIs, right? So we have also that. We have different formats. If we want to build an application that can leverage all these different formats, one option will be to select one vendor for each format, and then once you build the application, you will have the data that's coming from graph and from document and from relational, and all that you will combine at the application level. So you have to know how to use SQL, how to use projections in JSON, how to use Gremlin or some other kind of format for querying graph objects, and put that on top of the application level. You have to know all these things. Wouldn't it be perhaps a bit better, or at least as an option, if the database engine gave you the means to query all these different formats with one single language at the database level? Instead of doing it in Java or Python or JavaScript, if you could just talk to the database and say, I know you can handle all these different formats. So I just want the data. Can you give me that data? And by the way, I want that data in tabular format, or I want that data in graph format, or some other sort of projection, right? Wouldn't that be better? Perhaps for some, right? Well, that's exactly what we have here. It's called a convergent database. Again, Oracle is not the only one that does it. This is called multimodal in other database vendors. They do support other formats. It just so happens that the Oracle database is the one that supports the most formats under the same database engine. There is a version called the Autonomous Database. This is the version that runs on the cloud, which runs on the Oracle Cloud. It runs on Microsoft Azure. And as of 3 days ago, this Monday, Oracle announced a partnership with Google so that you can run the Oracle database on Google Cloud Platform, GCP. So there will be now more options to run this software. If you want to use this particular one, it so happens that there is an option for you to run it for free. You sign up for the Oracle Cloud, and this will give you access to not one, but two fully functioning Oracle Autonomous Database. You can address, I think this one gives you access to, I don't want to mistake it, I think it's 20 gigabytes. You also have access to 4 compute instances in ARM or 2 compute instances in Intel. You get a load balancer. You get 200 gigabytes of object storage and file storage. You can see all the details if you want to go here. And the best deal of this thing is that you get it for free, forever. You won't have to pay a single dime for using these resources. Yeah. There is another version of the database that we call Oracle Database Free. This one you can run on your laptop. You can put it on a server. You can put it on a Docker container as well. And this is the first time that the company decided to publish a version of the database that is readily available for developers first. Not for the DBAs, not for the CTOs, not for the CIOs. This was available April of last year. And the final version of this database was released this year. So we, as developers, got to play with this software much early on. By the way, that guy that appears over there will eventually reappear later. He's important because he's the one that has created a series of Docker images that allow you to run the Oracle database on Docker. There is the Oracle Container Registry, where you can download different kind of software. This is the autonomous database for free there. And there is the free database as well. So these images are a little bit big. They are like 8 gigabytes in size and take about 2 to 3 minutes to boot up, but it works. But of course, if we want to do tests, we want to be fast. We want to set up things as quickly as we can. We want to have that quick feedback loop. So we're going to use different images. These are the ones that you really want to use in combination with test containers. You can put them in production if you want to as well. For the latest version of the database, 23 AI and upwards, I would recommend you to use this particular set of the images. They are quite fast. They take less than 1 gigabyte in space for downloading, and they're starting about 10 seconds. So that's pretty good for test cases. If you need to test with lower versions, then you can use this one from database 11 up to 21. So depending on your use case, you may use one or the others. And this one also starts very, very fast, very quickly. OK. When I was telling about test containers at the modules, there are many different database vendors out there that are already supported. So you can see MariaDB over there. There's MSQL, Postgres. And there's the Oracle free modules if you want to set up with 23 and upwards, or the Oracle XC if you need to set up with 21 or lesser. And using these containers or any modules is as simple as that. Once you have put the library or the jar file, the dependency that provides the given container, then you just instantiate it, pass any image that you need to use, and you're done. Just start the container. Every other module that Test Containers provides pretty much works in the same way. It's as simple as this. OK. Now, another thing that will happen, and this is a good thing, is that in the past, when we needed to connect to an Oracle database, we needed to download the drivers from some page and then put them somewhere into a project. Hopefully, you didn't use the system scope in Maven. I did that in the past. You should not use the system. Who's using the system scope? If you don't know what the system scope is, good. Don't find out. It doesn't exist. Don't be looking for it, OK? But in the past, we needed to copy those jars and put them somewhere so our projects will resolve them. Since September 2019, we don't have to do that, because the Oracle drivers are finally available in Maven Central, just like any other dependency. Use them as is. This has enabled Spring, Hibernate, Vertex, Quarkus, Micronaut, every other framework to test out Oracle integration very, very easily, because now it's finally available in Maven Central. If you have any questions how to use those jars, or because there are more than one jar, we have put up a document that states all the different combinations and all the different reasons or use cases and scenarios where you might want to use this set of jars versus this other set of jars, how you can configure this in a Maven project or in a Gradle project as well. All right? Perfect. So now we can go into the demo. Let's see how it goes. This one went fine, so hopefully the other one will also be good. And let's see that. So this is a very trivial Spring Boot application that contains a domain entity. It's a customer. The application doesn't do much. We have a repository, and we would like a way to test out this. Now, it will make more sense if we definitely not need to test out the CRUD application or CRUD behavior that the repository provides by default, because we are expecting that to have been tested by the Spring Data team, right? We know that eventually will be some bugs hidden somewhere, as always, but usually we'll be testing the additions that we might make to our repositories. Okay, so I have first a test case where I'm showcasing just regular DbUnit. So this is the traditional way of testing. First, I'm going to set up test containers because I need a database instance. Before I can use DbUnit, I need that database instance. So let's see what we have here. I have defined the Oracle container because I'm using the Oracle Testcontainers module. So I just have to point it out to a particular database, a particular image. So it shows the latest version of the database. Good. What else? Before every test method, actually before all of the test methods, we're going to start the container once. And after all the test methods have been run, we're going to stop the container. So test containers will take care of this. We're doing this here very explicitly. And because the container will start with a random password and a random port, a random connection, we need that data such that the Spring Boot can connect to it, right? So that is what we're doing here in this dynamic property source annotated method. We are reaching out directly into the container at a certain point in the initialization of my test case to grab that data, modify the running properties of the dependency injection container so that when I actually need to talk to that customer repository, this Spring Bean, then the database has been fully initialized, and everything else, every helper bean that is managed by the container will have the right connection. That's the reason why we're doing this step right here. Connecting to the JDBC URL, getting the username and password, because all these things are generated by random. OK. Another thing that I have to do in the case of the traditional way of DbUnit is either I stand from a specific test case, this is JUnit 3 way to do things, don't do that, or we use composition. We have a helper method or helper class called IDatabase That, by the way, was one of my initial contributions to the project, where we say, I know that you have a data source object somewhere, a database data source bean. I'm going to use it to connect to the database so I can send data to it whenever I need it. Okay? So all this code that we're seeing here is making sure that we initialize that helper class properly. And then, before each test method, we're going to connect to the database, and we're going to put a state over there. And after we have finished every single execution of that method, in this case the teardown, is where we're going to drop everything and go back to the initial state that the database had before we actually run the test case. Okay? Then we have some code here that says we're going to load some database, some data set, and there's some weird class name called flat XML dataset builder. It is because the original DbUnit allows you to load data sets if they are defined using XML. Remember, DbUnit is a product of its time. This is more than 20 years old. Back in the day, XML was all the rage. For the newcomers, you probably prefer to use JSON or TOML or YAML. Sadly, DbUnit only understands TXT or XML. There are two different formats of XML that we can have, but in this one, we're going to tell, hey, database, we're going to add 2 rows to the customer. And when we run another test case, we're going to insert a new element, and I want that data set to be the correct one. So we can see that in this test case. We find the first object by a last name. Here we're just using the regular Spring Boot API. But we're able to find that object because DbUnit was able to insert those two customers in the table that I expected, right? But in the second test case, we create a new domain instance, we persist that domain instance, and we use DbUnit to grab a copy of the current database view, everything that is currently in the database, all the tables, and then I just grab the customer table out of that data set. So this is my current representation of the database. And then I load the other data set, that customer added, that XML that I showed you that has 3 elements. And then I do a comparison of these 2 data sets. And if they happen to be equal, we're good. If they are not equal, something happened. Either I made a mistake with the data set, or the operation that I was expecting to be run successfully actually encountered an error. All right? So yes, this works. But as you can see, there's a little bit of additional work that you have to do in order to verify states, and additional work that you have to do in order to put the original state, right? There are better ways to do it, and this is where Database Rider comes in. Notice that in this case now, I have annotated this test case called the Spring Boot test, DB Rider, and Testcontainers. With this, I'm now making sure that my test case is aware of the container, the dependency injection container, that Database Rider will be able to execute additional code given certain annotations that we'll see in a moment, and that the Testcontainers object that we saw before, that Oracle container, will be managed. So I don't have to explicitly say start or stop the container. It will happen automatically for me. I just need to say, hey, I need a container. Then everything else, Testcontainers will take care of that. I still have to tell the dependency injection container, these are the settings that are coming from the random values generated by the container. Otherwise, I wouldn't be able to connect to. We still have the customer repository that we saw before. But notice that there is no helper class there. There's no need to do explicit support for how to load a data set. That happens on each one of the test methods that we saw before. The actual test code is the same. Just that the setup, it says, now they have a notation that says, I have a data set that is coming from that customer. In this case now, look at that. It's a YAML file. And I want to have an expected data set from another YAML file. So in this case, I'm just querying, I'm just grabbing data. I should not be modifying the state of my database, right? So that's why the original data set and the outgoing data set should be the same. If that is not the case, our simple query did something that it shouldn't. And in the other test case, we have one data set and a different data set. And we just say, create a new entity, store it, let's see what happens. So when we look now at the data set, here is the version in YAML. We have 2 objects. And when we add 2 customers, we have 3 rows. It's as simple as that. If I run the test cases, where is my terminal here? Here we go. Let's do a clean to make sure that nothing fake is happening. So we're running Maven. And where is this? I want to be bigger. Oops, that was not what I wanted to do, but this works. There we go. So you can see here that Testcontainers has located that particular version of the image. Now has started. The test case is running. We see an exception. This is a problem that was recently fixed. This is caused by the latest version of the Oracle database, 10.3, when we wanted to drop a non-existent sequence. Even though that sequence did not exist and we got some sort of stack trace, the test case continues. This happens with the latest version of Hibernate, but it will be fixed in the next version. I think it's either 6.7 or the latest versions of 7.0, which is, if I'm not mistaken, currently in beta. OK, now is DB Rider running here. We have additional information about the test case, and there at some point says we run 2 test cases. There were no failures, there were no errors, and I think that right now Testcontainers is trying to kill the containers, and it might spit out some sort of network issue or some sort of timeout. But until right now, all the test cases that we had 2 test methods in 1 test case, and other test methods in 2 test cases. So 4 test methods in total, and all of them should be fine. So even though we saw some error there, because we could not connect to the container that was already dead, in the end, we had 4 successful test cases. Every single time that I run this test case, I will get a new database, fully configured the way that I want it, the way that I need it, and it's not shared with any other of my teammates, any other process, or a CI server. It's just there exactly when I need it for running my test cases. This is why we want to use test containers. And we use DbUnit and Database Rider to ensure that the database is in the right state and to also verify that it has the right state as well. OK? Someone may be asking, yeah, this is nice, but I need to create those data sets. This demo is so simple. It's just one table and a handful of columns. I have to build production-ready software. It's hundreds of tables with millions of rows. How can I test this? Do you expect me to write XML or YAML for all these different scenarios? That's too much, right? Well, guess what? The DbUnit developers also think the same. I didn't show it, but there is a way that you can configure DbUnit to connect to the database and grab the data set and export it in the way that you need it. So once you have these exported data sets, you can still do some managed work and manual work and see, just remove some tables or remove some columns so you can get the scenario that you actually need. So you don't have to start from scratch. I don't know if there is a translator from XML to YAML that DB Rider exposed. If there isn't, then there should be one, I agree. I also think that in the future, it would be great if DB Rider supported more formats. So TOML is great for defining tabular data, or you could want to use JSON as well, yes, instead of just YAML. So we'll see. The creator of Database Rider is quite active, so the community is still going. And DbUnit is a little bit as well, so it's quite established. So if you happen to use any of these tools, and if you see that it's something maybe missing, or there is a feature that you think it would be great to support this and that, then get in touch with those projects and let them know about your ideas. Okay, just in case that if you were not able to use test containers, or DbUnit or Database Rider, you can also, if you happen to use GitHub for either it's commercial, enterprise, or open source, then you can also run the Oracle database on GitHub on your own if you want to, or you can use this GitHub action. This allows you to set up the database very quickly, such a way that when you write your GitHub, this is an image, so I cannot show it if I cannot scroll it. But the way that you set up your image, you simply say, use the version 1 of this database action, supply what is the version number that you want, and then I think that you may set the username you want to, or the password, or have those values generated by random. And poof, you got a database that is running. Again, this database will be running outside of process, outside of your test cases, but you will have a running database that you can connect to and then do whatever you need to it. OK, so in closing, I have some resources for you. Testcontainers.com is where you find all the information about test containers, documentation, and the modules. There are more modules that have been added every month. And the community meets at Slack, testcontainers.com. It's quite active. You can find DbUnit in dbunitsourceforge.net. Anyone else remembers that particular SourceForge? Most people know what GitHub is and GitLab. But SourceForge, this is where the source used to be, way in the past. And of course, Database Rider, this being the new guys, they are hosted on GitHub. If you want to know more about different Oracle settings, then I have this for you. The first URL is probably the most important one. This showcases not only how and where you can download the free database, but many other projects, services, tutorials, videos, everything available for free. Many of them open source as well. So if you want to take a screenshot of this one, this is the money shot. And there are other resources. But most importantly, let me remind you again, you can run the database on the cloud. You can run the database on your laptop, on your server, on Docker, and all these different versions, you can run it for free. There are other versions that you can have access to, of course, but you can get started with these particular editions. So, last thing is that all these things that we saw today, and with any other things that you see today at this conference, you will learn about new technologies, new methodologies, new tools that may appeal to you. You say, oh, yeah, this makes sense. I'm going to bring it back to my company. I'm going to showcase it to my teammates. And then they say, no, we're too busy. We need to deliver to production. We cannot use these test cases. We cannot use these things because we have to do this. I get that. So don't be discouraged. Build a proof of concept. Showcase that to your manager, to teammates. And very likely they're going to see why it makes sense to continue exploring with these particular ideas and these tools. All right? One final thing is that if you have not contributed to open source before, let me tell you, it's quite simple. If you find any problem with what we see today or any other open source technology or dependency that you use at work, file a ticket. Whether that is a bug or a missing feature or something that might need some change, file a ticket. That's it. You don't have to send source code. You don't have to send test cases, nothing like that. If you have the time and the passion, certainly do so. But at the very least, let the person at the other side of the wire that something is going on with the project, whether it's good or whether it's bad, so that we can all grow. Let me tell you, that's plenty of help for us that work on open source. So with this, I thank you very much. I thank you for your time, and we still have like 2 more minutes for any questions in case that you have them. Well, those lights are very bright. I cannot tell you. You won't believe me how very bright they are. So, any questions? If not, well, thank you very much, and keep continuing during DevBcn.